Just wanted to have a quick look at this pilot-operated relief valve. I'm just going to talk a bit about auxiliary mount type like this and another style of auxiliary mount that would connect to a manifold. But I'll just look at a couple of different types of auxiliary mount pilot-operated relief valves, and I'll compare it to something like this that might be found in a more modern mobile hydraulic system. This is a cartridge style pilot operated relief valve, and I'll compare all the pieces, and it's basically just a miniaturized version of this, but some comparisons we can make as we go. So the auxiliary mount relief valve I have here is also what's known as a balanced piston design, because when we take the pilot section off the top here, this is basically where the pilot poppet and pilot poppet spring live. But in the lower section here, or in this one, we've got an unloading valve, and it's a balanced piston design. So the balanced piston unloading valve kind of looks similar to a balanced hydraulic cylinder in that it's got the same effective area that pressure can act upon on either side of the piston. So you can see we've basically got the same annulus area here that we have on this side of the valve. So if you've got the same pressure either side of this unloading valve piston, it's going to have the same forces, and therefore it's not going to want to go anywhere due to hydraulic pressure. And then it's also got this fairly light spring, which I like to call a bias spring. Sometimes it's called the unloading valve spring or the balanced piston spring, but it's a bias spring really, which we see a lot of in hydraulics because it's biasing that piston in one direction to want to keep it down and closed. And down is closed. For the unloading valve, again, we've got two styles of body I'll talk about, but for the unloading valve, it's easier to see the function in this sort of manifold mount style valve. So this valve is designed for this surface to bolt up to a manifold or other components that would have the supply pressure from the pump feeding into here, and then this passage would connect back to the tank or reservoir. So we have low pressure here, high pressure here, and this would mount up and seal with these O-rings obviously on the flange. And then hopefully I'll remember to talk about this hole later. That may or may not be used depending on the application. But when this unloading valve is down, you can see this polished part of the spool fits very snugly with very tight clearances into the valve body. So that creates a metal-to-metal seal in there that basically closes off the high pressure side of the system from leaking back to tank. So when the valve is closed, and like any relief valve, these relief valves are normally closed, non-passing of oil, and once system pressure reaches a value higher than the setting of the relief valve, what we want to happen is this unloading valve to lift, and when that unloading valve lifts, because of the notch in the spool here, there's a big clearance for oil to go from pump to tank. So this valve is going to do, this is the business end of the valve. This is what's going to process the oil to return from the high pressure side of the system back to tank in large quantities when the relief opens. So that spool moving out of the way could allow tens of GPM to go back without causing any serious restriction. So unloading valve lifts, dumps the oil. How it's controlled, when you first look at it, it doesn't really seem logical that we're going to put system pressure underneath this area and only have a fairly light spring on top holding this unloading valve. You don't really see initially what's going to keep this from just lifting against that light spring and letting the oil go to tank at relatively low pressures. And what's involved in keeping this unloading valve down besides this light spring has to do with this orifice. So there's an orifice through the unloading valve, and you always want to inspect that orifice if you have one of these apart to make sure you can see light through that passage. So you should always see light through the orifice from one side to the other. And what that orifice, what its job is to take whatever pressure here is on the high side of the system, pushing underneath that poppet, to also come up through that orifice and fill the top chamber here. Again, balanced piston, we want the same pressures both sides to keep that unloading valve down. And then you might wonder, how is it ever going to open if we've got the same pressure both sides of a balanced piston and same effective areas, and then we get this bias spring keeping it down? Is it ever going to open? Well, it will, and how it will open is basically got to do with the pilot poppet. So the pilot poppet housing sits up here, and of course the adjustment is for the pilot poppet spring, but also through the adjuster on this type is how you would access the pilot poppet and the pilot poppet spring. And this orifice right here, this hole, basically connects the top side chamber of the balanced piston to go in and be sensed at the nose of the pilot poppet. And I'll just grab the pilot poppet out of this valve and we'll have a look at it. So I paused the camera there because I had to make some noise to get this out. On this style there's a plunger with just an O-ring holding it, and if you can hook something in there and pull that plunger out, you'll get the pilot poppet and spring. But the pilot poppet and spring then sit in behind the adjuster, and of course the adjuster is going to adjust the tension on the pilot poppet spring, because the pilot poppet spring is what's going to control the opening pressure of this valve, of this relief valve. So the pilot poppet and spring, when they're in their housing, sit up here perpendicular, and again, coming up from the top side of the balanced piston, pressure is going to be sensed at the nose of the pilot poppet. And if the pilot poppet senses its setting pressure, let's say for discussion purposes, this spring is set at 2000 psi. If the pressure gets to 2000 or 2001 psi, the pilot poppet's going to unseat and let a small quantity of oil out, maybe a teaspoon or a teaspoon per period of time, very small quantity. And that oil then is going to return to tank from behind that pilot poppet. And when it does that, it's going to break the hydraulic lock on top of this balanced piston. So the pilot poppet's going to let a small quantity of oil out. That's going to break the seal or break the hydraulic lock on top of the balanced piston. Then the balanced piston is going to lift because we still have high pressure underneath it, but the pressure on top has been relieved. So the pressure differential now is going to cause the unloading valve to lift, and it's going to lift fully. And then again, whatever the system flow is can pass the spool here through the clearances in the bore and go back to tank. So we're going to use a small quantity of oil, teaspoons, to control gallons per minute. So teaspoons per minute, maybe controlling gallons per minute. And that's kind of the same concept of a relay, as a relay in electrical systems, where you use a small amount of current to control a large amount of current. But there's many benefits we'll talk about in a second here. And as you let that oil off, again, you're letting teaspoons out only, and you might think, well, isn't oil going to come back through that orifice and just replenish that missing oil? And it will try, but because the orifice is very tiny, it's smaller than would be required to replenish all the oil that's being let out by the pilot poppet. We're going to maintain that pressure differential or pressure imbalance, and the unloading valve spool is going to stay up, dumping that oil. Once the pressure spike or high pressure condition subsides, the pilot poppet will reseat back onto its seat and reestablish the hydraulic lock on top of this valve, and of course oil's still flowing up to the orifice, so that's going to close the unloading valve. So the order of operations is we get a high pressure, pilot poppet unseats, breaks the hydraulic lock, unloading valve lifts, pressure is relieved, pilot poppet reseats, unloading valve closes again. Now, the tricky part about the design of this valve is when this pilot poppet opens, it has to let those teaspoons out to tank, and it may not be immediately evident where that's going to happen. But the magic for that is the center of this unloading valve, where the little bias spring lives, is actually hollow through there. If I just take a piece of white paper, and you should be able to see that through there. So you can see this, the unloading valve, the balanced piston spool, is actually hollow, and because drain is out the bottom here, that hole proceeds right out the bottom. So that's how the teaspoons of oil actually get out from behind the pilot poppet. They bleed off here, go down into a sealed chamber. This actually fits in a bore when the bias spring is in there, and it allows the oil to return to tank without having to let system flow return to tank. So again, that's hollow where the little bias spring sits. So again, the parts, the balance piston unloading valve with the orifice in it, and the bias spring or the lighter spring. It's a longer spring than the pilot poppet spring, but I can compress it fairly easily. I've seen textbooks discuss 30 psi as maybe a typical value for that spring, and it's just there to bias the balance of the piston. This spring, of course, is going to control the maximum pressure setting, the pilot poppet spring, and in my example here, 2000 psi. And again, if you've got the flow-through style housing, this housing is designed to bolt up to a manifold or other components. If you've got a flow-through housing, oil could enter from either direction and go right through the body and be sensed underneath the balance piston unloading valve. Same design, it's just a little bit different housing that it lives in. And then the return to tank is still out the bottom here, so pressure would be sensed as oil flows through either way, from the pump probably to the DCV. And then this one looks like it's got a port to check pressure. The other port I wanted to get back to on this design is for remote sensing or remote control. Some installations may have two pilot-operated controls, one at the relief valve, as you'd expect, and maybe another one with a remote line running to it. And this here would be capable of connecting to another passage, basically the equivalent of this one that would go to another pilot-operated relief valve. So I'm assuming, not exactly familiar with the application of this specific part that's on the bench here, but I'm assuming that's why that's there. And in some manifold applications where bolted up, that may just be sealed off and solid steel across there to not connect it to anything. So that is a pilot-operated auxiliary mount style relief valve, pilot-operated relief valve, and this is a balanced piston type. And I wanted to make some comparisons between that type and a cartridge style pilot-operated relief valve. Not sure who the manufacturer of this guy is, but basically this is the same valve with all very similar parts. It's not a balanced piston design, but there's our pilot poppet and spring. And instead of sitting perpendicular or horizontal as it would relative to the unloading valve, this one, of course, they just sort of turned it 90 degrees and installed it in the end, and the adjuster here is a lock nut. And then this is, of course, a cartridge type, so pressure would be sensed on the nose of the valve. These radial holes here would exhaust back to tank, and the cartridge or directional control valve, as it might be installed into, would be cast inside a machine to have high pressure, pump supply pressure on one side if this is a main relief, and return to tank out these radial passages around here. And of course we've got a straight thread O-ring or O-ring boss type connection that would install it into the cartridge. And an O-ring and a backup ring here that are very important, that I'll come back to in a second. So we take so we've looked at the pilot poppet and spring, which look very similar to the parts in a balanced piston style auxiliary mount valve. And then if we go a little deeper in, we got some more soft parts, some more seals. The unloading valve in this one actually has two bias springs, two very light springs, but one's around the cup, and the unloading valve now becomes this cup shape. So in the housing, instead of a balanced piston, got kind of this cup shape unloading valve. And then we've got another light spring in this particular manufacturer's valve. So we've kind of got two bias springs now instead of one. And the orifice through the unloading valve now becomes a separate piece. And again, we want to check that and make sure we can see through that, and it should be clear inside. So yes, we've got our orifice piece that we can see through. And if I'm lining it up there, it's hard to see if I'm getting that correctly on the camera. Yeah, there we are. You can see light through it. So that's the orifice piece. Instead of being part of a balanced piston now, it's a separate part, and it installs through the unloading valve cup. So it's going to install like that, and when it's in there correctly on this manufacturer's valve, it sticks out quite a ways. So that's now our unloading valve. So it's going to have pressure sensed on this side. And again, when you look at the springs, you think those springs are so light, they're not going to be able to hold this valve shut. But again, oil's going to come through the orifice, and get on the cup side of the unloading valve, and it's going to lock that valve shut hydraulically. Then in further back in the stem, or in the cartridge unit, the pilot poppet and spring are going to control the draining or draining off or hydraulic locking of the unloading valve. And here there's holes around this part of the valve that are going to return back through the clearance around the valve back to tank. So when the pilot poppet unseats, that a teaspoon of oil or two are going to come out of here and go back through the body, back to the radial holes, back to the low pressure drain side of the system. So now we've got our unloading valve as a cup with a separate piece for an orifice, two biasing springs that are working to help keep that unloading valve shut. And another reason for those bias springs, obviously if this cartridge was installed this way on the machine, well then the unloading valve would want to fall open. So it's kind of assisting in the hydraulic lock, keeping the unloading valve section shut. And then of course the pilot poppet spring and the adjuster. And another function of this valve, if this isn't a main relief in a system, but rather it's being used as a port relief or a line relief, as it may be called, in an actual work port of a circuit going to a hydraulic cylinder, then the unloading valve cup here may also work as an anti-cavitation valve, or sometimes called a makeup valve. Whereas if we get a vacuum on this side of the valve, the vacuum can travel through or negative pressure or vacuum can travel through the orifice, get into the cup side where the light springs are for biasing, but the vacuum can pull that cup off its seat and allow oil to come backwards from the tank and replenish a vacuum or a voiding condition in a hydraulic cylinder circuit. So this is actually what I've got on the bench here, is potentially a combination port relief and anti-cav if it's used in a port relief situation. And just wanted to review those parts. Putting this back together, the trick is these little springs. So what we want to do is, obviously we'd want to clean these parts, but we're putting the pilot poppet spring. This is just used for training purposes. The orifice has its own little spring now, or the bias spring, not the pilot poppet spring, but the orifice has its own small spring. The unloading valve cup has a spring as well, and then they of course are guided by this part of the valve housing. When that goes together, we want to make sure that small spring didn't get bounded, and I had the spring fall over in there, so it's not sitting correctly, so I need to reestablish that. So I always want to check that with these small parts. I want to make sure that spring isn't all bent as well, which can happen. And again, I'm putting that on the guide. Now I've got nice light spring force behind the orifice piece, and the whole unloading valve cup moves very easily on the back side of the housing. And putting that together into the valve body, just want to make sure everything stayed together there. And again, rechecking that light spring force for the orifice, and then the pilot poppet and pilot poppet spring can go in there, and the adjuster. And also back to the O-ring and backup ring. Of course, we have highest pressure in the entire hydraulic system here and lowest pressure in the hydraulic system here. We got a big potential for a problem if this O-ring and backup ring are not in good shape. So first of all, we want to make sure installed in the correct order. The O-ring faces the pressure side of the circuit, the backup ring backs it up, and you always want to make sure that seal's in good condition and lubricated properly at assembly, so when it goes into the cartridge it doesn't get damaged. In some applications there may be warnings in the manual about how long you would want to stall a particular hydraulic function at main relief pressures, and some may, for testing purposes, specify a very short period of time because they're afraid of localized heat in this area actually melting that O-ring. But I've seen these O-rings very brittle and hard and damaged, and on a main relief application, a cut in that seal, when the oil gets warm and the viscosity goes down, a lot of oil can sneak through that clearance that's supposed to be sealed. So I've seen a lot of main relief issues blamed on a cartridge valve, when probably a very cost-effective part replacement here of the seals would have handled the repair. But that's again just comparing balance piston type auxiliary mount pressure relief valves to cartridge type with a cup shape unloader, but a cartridge type pilot operated relief valve. Hope that helps.